Let's look at some solving using special segments. On number 8, they're telling us that DE is a midsegment over here to the side. Remember that to be a midsegment, that's a segment that connects the midpoints of two sides of a triangle. So if DE is going to be a midsegment, that means that D is the midpoint of HG and that E is the midpoint of HJ over there. So we have some congruent segments just from knowing the term midsegment. Another thing that we know about the midsegment is that it's parallel to the third side. And by third side, we mean the side it's not intersecting, which would be GJ. So DE is parallel to GJ, which can give you some angle problems that you could have to deal with. And another thing about the midsegment is that the midsegment is also half of the length of the third side. So DE is half of GJ, or you could consider it to be 2 times DE, which is the way that I like to work that midsegment problem, is equal to the length of GJ. So let's look at what they have given us here. They've told us that DE is 4x plus 5, and they told us that GJ is 3x plus 25. So if I want to label those items in the picture, my 4x plus 5 would be here, and the bottom would be 3x plus 25. So we're going to be using the rule about midsegments where if we double the midsegment, we're equal to that third side. It's just easier to double something than it is to cut something in half, so that's why I like to use that version of it. So we're going to do 2 times the midsegment, which is 4x plus 5, equals to the third side, which is 3x plus 25. I'm going to distribute the 2 here, just getting my algebra solving going. And subtracting 3x from both sides. Subtracting 10 from both sides, isolating my x term, and dividing by 5. That gives me the value for x, but the question is, what is DE? So we have to take our x value and plug it into segment DE, which would be 4 times 3 plus 5. So that's going to be 12 plus 5, and that gives us that DE is 17. And that is all that we need to do for number 8. On number 9, we have enough information in this image to be able to tell that line DB, because it is making a right angle with line AC, and because it is also bisecting segment AC, and we can tell that from those congruent segments, that tells me that DB is a perpendicular bisector. What I know about perpendicular bisectors is that any point on the perpendicular bisector, such as point B, is equidistant from the endpoints of the segment it is bisecting. And this will allow me to know that segment AB is congruent to segment CB, and that lets me set these expressions equal to each other in order to solve. So I'm going to subtract the 3x from both sides. I'm going to add the 16, divide by 4, and I get my x value. They wanted me to solve for x and y. This doesn't even have a y, so that's the answer for that one. Number 10 is a very similar, as a matter of fact, like the exact same picture. So we're using a perpendicular bisector again. So perpendicular bisector, we got a right angle, we got our bisecting there. And that tells me that the segments from there, which are labeled, are congruent to each other. But the problem with this question is that this has a y, this has an x, those are equal. This has an x, this has a y, those are equal. So the issue is that I have a system of equations that I have to use to solve. So one equation is 5x minus 1 equals 3y. The other equation is 2y plus 1 equals 2x plus 3. So in order to solve this system, it's like they're not in standard form. They're not in any normal kind of format. So we have to choose one of them and solve that particular equation to get one of our letters alone, and then plug that into the other equation for that letter. I don't like the looks of the 5x minus 1 equals 3y. If I were to divide by 3 to get y alone, we would get really gross numbers. So what I'm going to do is I'm going to use the equation on the right, and I'm going to solve for y. So I'm subtracting 1, which will give me 2y equals 2x plus 2. And then I'm going to divide by 2 everywhere, which is actually going to work out really nice. Gives me that y equals x plus 1. Now that I know what my y value is, I can take that y value, or that expression that is y, right here, x plus 1, is representing the letter y, and you have to substitute it into the other equation. Do not put it into the same equation that you got this expression from, or it's not going to work out. So we're taking this and we're going over to this other equation where the y is at, and we're going to replace that. So in that replacing, you're going to see 5x minus 1, which is already there, equals, and the 3 was already there. Where the y is inside of parentheses, we're going to put x plus 1. So we're just replacing what the y is, because y is equivalent to the expression x plus 1. In order to continue the solving here, we're going to distribute the 3, which will give me 3x plus 3. And solving for x, I'm going to subtract the 3x from both sides, giving me 2x minus 1 equals 3, and adding the 1 there, 2x equals 4. Dividing by 2, x is 2. That gives me my x value. Once we have our x value, we're going to take that back over to the expression for y, and we're going to use that value to find our y value. So y is equal to our x, which we found out is 2, plus 1, and that gives us that y is 3. So just having to use systems and substitution, because the equivalent segments were having different variables on them. So that makes it a little bit harder to do. Let's look at number 11. Number 11 and 12 use the picture on the right. And number 12 has like this BD, I guess, goes over there. So let me just copy that there. Kind of got separated because of the picture. And they are starting, and I might like erase this after we use it, but number 11 says AB is equal to BC. Because when we do number 12, we're going to start over on this picture. So AB is equal to BC. What that tells me is that these two angles at the bottom are equal by the isosceles triangle theorem. And we want to find the measure of AD and the measure of angle ABC. So what is true is that if you have an isosceles triangle, which we have right now, and you draw in the height of that triangle, the height of the isosceles triangle will split the base equally. And we could prove this as you are looking at this triangle that I just drew, my isosceles, and I drew in the height. What it creates when I draw this, and I have that right angle, is that we could prove these two triangles are congruent by angle, angle, side. And that allows me to know that the base is split in half and that the angle up top is split in half. And so these are the things that they want us to see from this picture. They told us it's isosceles. We can see the right angle there in the bottom. And so that lets me know that AD is equal to DC, which would mean that AD is 12, and there's really no work to show for that. And then we can also find the measure of ABC, and the measure of ABC is all the way from A to B to C, so it's putting together these two angles at the top, and we already have one labeled as being 39. So what we need to do is take 39 and just double it, which would give me 78. So the measure of angle ABC is 78 degrees. So there really wasn't any, solving that we had to do on that question. We just had to recognize if we know those sides are equal, then it's isosceles, and then what that does to the base when you have your height drawn and everything. On number 12, we're using the same picture, but on this one, they have used the word centroid. Remember that a centroid is formed by the medians, and it splits those medians up into like a 1/3, 2/3 relationship. They said that we are supposed to find FG and BD. So let's look. For FG is located right here. FG is a part of the median. It's the short part of the median AF. They've already given us the long part of that median, which is AG, And the long part and the short part are related in a way where the short part is 1/2 of the long part of the median. And so if we already know the long part, which is 13, then we're able to take 13 and just divide it by 2. So FG or GF is 13 over 2, or you could write that as 6.5. We don't like decimals, so I'm just going to go with 13 over 2 because that doesn't reduce. They also asked for BD, which I didn't notice until just now how that's all the way over there. BD is the whole median, and part of BD is labeled. They have labeled the long part of BD as 10. If we wish to find the short part of BD, that would be 1/2 of 10, or 5. And then that allows us to find the length of BD to be the sum of those two numbers, so just 15. So that is how we can use the medians, which come from the centroid, and if they're just number related. We do have an algebra one on here in a minute. Number 13 is probably the most complicated algebra solving that you have to do on the entire review. And I've already highlighted a triangle in this image here. It says that J is the in-center. Remember that when you have an in-center, this is formed by the angle bisectors. So we could label some angle pairs as being congruent, but this question doesn't have any angles labeled, so really we don't care about that. What we care about the in-center is that it's the center of the inside circle. And the center of the inside circle means that JL is congruent to JK is congruent to JG. Those are all radii of this circle. That allows me to take the expression of x plus 5 and write it down here for JG. This ends up having you have a right triangle where it's sort of shaded in that bluish color. We're ending up with a right triangle where all three sides are labeled with expressions. And when you have to do right triangle problems involving the sides of right triangle, you're probably thinking Pythagorean theorem. This is what we're going to be using, except we are using binomials for A and B. And this is what makes this question algebraically the hardest one. So I'm filling in my a squared and my b squared and my c squared. It's going to be 20 squared there. That part will be easy. It's the binomials that are the tough part. When you are squaring a binomial, you can use different methods to multiply. You would have already done this in algebra, but I know it's been quite a while. When you're multiplying and squaring a binomial, what you have to do is you have to write it twice. A very common error is just to square each part, and if you square each part, you're going to get 9x squared and a positive 25. But that is not going to be correct for the product of 3x minus 5 times 3x minus 5. I'm going to use the FOIL method, it's one of my favorite methods, and you do not have to use this method for multiplying, but you're welcome to if you would like. FOIL stands for first times first, which will not give me 3x squared, it'll give me 9x squared. 3 times 3, x times x, and then outside times outside, inside times inside, and last times last. That's what that FOIL stands for. It doesn't work for anything more than binomials though, so it's kind of a bad method. Double distribution is going to be the most common method that we use in our algebra classes. I'm going to combine like terms, so we get 9x squared minus 30x plus 25. So that comes from that first set of binomials. Notice that the middle term would be missing if we had made the mistake of just squaring the two parts. Now we have the next trinomial, which is x plus 5 times x plus 5. Again, and I like the FOIL method because if you look at it, I don't know if you see it or not, but it kind of looks like a little face to me, and that just makes me smile, so I just like it. First times first, x squared. Outside times outside, there's a little mouth. 5x. Inside times inside, there's the little nose. Last times last, those are the eyebrows up top. So we get x squared plus 5x plus 5x plus 25. Combining the like terms there gives us the middle term of 10x. And continuing on the right side, 20 squared would be 400. So I'm just going to copy that down. So at this point, on the left side, I have two trinomials, and they have like terms. So I'm going to combine my like terms. I'm going to combine my x squareds and my x's and my constants. And this will give me 10x squared minus 20x plus 50. Just double checking, 10x squared minus 20x plus 50. Okay, equals to 400. And what makes me excited about this trinomial, I'm solving, and it's a quadratic, and no, I'm not excited about that part. That's the part that makes this a tough problem. But 10 is the lead coefficient. And if you look at each part of the equation here, 10, negative 20, 50, 400, all of these numbers are divisible by 10. So dividing everything by 10, including the 400, will make me have an easier equation to solve. Dividing by 10, I get x squared minus 2x plus 5 equals 40. Now, in order to solve a quadratic like this, you have to have your quadratic equal to 0. So we're going to subtract 40 from both sides in order to get our equation equal to 0. So I'm looking at the trinomial x squared minus 2x minus 35 equals 0. And I have to factor that to solve, so I'm just going to bring it over here to have a little bit more room. Remember, when you are factoring, you have your product of a and c up top, your b on the bottom. You think about the factors that will multiply to negative 35 and add to negative 2. These are negative 7 and positive 5. And you can split that middle term and do the long process, or if you notice that your lead coefficient is 1, then you can go straight to your factors. Your factors will match with these here on the side, so x minus 7 and x plus 5. That only happens when your lead coefficient is 1, and that's why I was so excited that we could divide by 10 back there. So our factors are x minus 7 and x plus 5, and you use the zero product property to set each of these equal to 0. What that does is that if either of these binomials equals 0, then when you multiply them together, you're going to get the value 0. So if you set each one equal to 0, you're going to get your options. I could have 7, or I could have a negative 5. Now, before you decide on if they both work, you want to go look at the picture. You want to think about, if I plugged in a 7, would that be okay? If I plugged in a negative 5, would that be okay? Well, look at this. If I plug in a negative 5 right here, I'm going to get 0 for the length of a segment. That makes no sense. So you don't want to have negative 5 as an answer choice, so you want to get rid of that one, and you want to just keep the answer of 7 for x. So we have found that x is 7, and they also wanted jg. jg is x plus 5, so jg will be 7 plus 5, which is 12. So now we have our x value, and we have our length of jg. Definitely the most complicated algebra that you will have to do. Let's look at number 14. It too has some algebra that is tough. It does have some factoring in it, but at least it doesn't have binomials that you're having to multiply together. Notice that underneath the image it says that we have a centroid. Centroid is formed by the medians, so we have medians in this picture. That means that F is the midpoint of AC, D is the midpoint of BC, and E is the midpoint of AB. They've given us BP, which is the long part of the median. So you have BP, which is the long part of the median, and BF. Well, BF is the whole median. So BF is the whole thing. And we learned in class that when you have medians, that the long part equals 2/3 of the whole thing. And so we can write an equation replacing where the word long is with x plus 4 and replacing where the word whole is with x squared minus 1. So the long part of the median, x plus 4, 2/3. The whole thing is x squared minus 1. I'm going to zoom in, make my pen a little bit darker there. I'm going to distribute the 2/3. 2/3 x squared minus 2/3. Now, dealing with a quadratic is already complicated. Dealing with a quadratic that also has fractions, not very fun. So what you want to do with your equation when you have fractions in it is multiply by what would be the common denominator in order to eliminate all of your fractions. When we multiply everything by 3, we will get 3x plus 12 equals 2x squared minus 2. Now I can see that I have x squared and x's, and I feel like I can bring everything to one side and then solve the quadratic. So I'm subtracting the 3x's, and I'm going to subtract the 12. This is because to solve a quadratic, you have to have one side of your equation equal to 0, which is going to be the left side. You always want to keep your x squared positive. It was already positive, so I didn't want to move that. Combining terms on the right side gives me 2x squareds minus 3x's and minus 14. Unfortunately, I'm not able to divide everything by 2 because the -3 in the middle is not divisible by 2. So I'm just going to copy this over here to have a little more room. And I'm going to be factoring. And I'm going to have to do the longer process for factoring. So up top is a times c, which would be -28. On the bottom is your b term, which is -3. Factors that multiply to -28 and add to -3 are going to be -7 and +4. Looking at your trinomial, you're going to be splitting that middle term into a -7x and a +4x. You want to put the one that goes with the term that's over beside it, like 2x squared would be kind of bad to put that -7 with it. It's better to put the +4. So you're going to put your 4x there. You're going to put your -7x here. Remember that what you're doing with this particular process is that you're splitting that middle term strategically in a way that is going to create like terms that combine to the middle term, and that those like terms, coefficients, multiply to that AC product. So this is an equivalent expression to the equation above it. We've just split that middle term so that we can factor by grouping. When you factor by grouping, you look at the first two and you look at the second two and you factor out the greatest common factor. So out of the first two, the common factor is 2x, which will leave me with x plus 2. In the second pair, you have to be very, very careful, and you have to look at the sign on that term there. You have to factor out whatever sign this is with the term that the greatest common factor that you're factoring out. So like I could take a 7 out, or I could take a -7 out. You want to take the -7. It's dependent on whatever the sign is of that term. So I can factor out a -7, which will leave me with x plus 2. If I did not take out the -7, I would have had -x minus 2, and it wouldn't match this set. You want those two parenthesis sets to match. Next, I'm going to factor out this parenthesis quantity of x plus 2, which will leave me with 2x minus 7. And we are still having that equal to 0 now that we have factored it. And we can separate the two factors equal to 0 to find our options. And we're almost done. This will be -2. And over here, we would add 7 and divide by 2, so it's going to be 7 over 2. Now, you want to think about if these work for this situation. If you plugged in a -2 right here, then you would get +2. +2 is okay to have. If you plugged in a -2 right here and squared it, you would have a +4 minus 1. That would give you 3. And if the long part of the median is 2, then the whole thing would be 3. That does work. We can also plug in that 7/2. We would get positive values, so I felt pretty good about that one anyways. But there are 2 answers to this one. They both work. Let's look at the last little bit. This is all just vocabulary, so it will go pretty quickly. Says to use figure A for the remaining questions. So part A is saying BD can be proven to be what? Well, go look at BD and look at what is, what signs or symbols you have around it. So BD has this right angle marking. And if all you have is a right angle marking, and you are going from a vertex and you are making a right angle with the opposite side, this is what an altitude does. The altitude is like the height of the triangle. It would only have a right angle marking. Part B is looking at AE. If you look at AE, the markings that are related to AE are these congruent segments. What that does is it tells me that point E is a midpoint. If you have a line that goes from the corner of a triangle to the midpoint of the opposite side, that is called a median. Part C has us adding some information. So I'm going to go ahead and I'm going to erase some markings that I have on here and focus really good on what they're giving us. They are saying that DE, which is here, is perpendicular to BC. That means that we would have a right angle marking here that was not in the original picture. And E, we already can determine based on these markings, is a midpoint. So segment DE actually has 2 things going on. It has a right angle, which makes perpendicular. There's a perpendicular relationship. And it's going through the midpoint, which means that it's a bisector. So segment DE would be a perpendicular bisector. The last one is only telling us that angle BAE, okay, that's right, get a different highlighter. BAE is right here. So BAE is congruent to EAC, and that is right here. And so if we have congruent angles like that, where we have one angle split into 2 congruent angles, that means that you have an angle bisector. And so that means that segment AE is an angle bisector. And these are 4 of our special segments that we just learned recently. Altitude goes from a vertex, makes a right angle with the opposite side. Median goes from a vertex to the midpoint. Perpendicular bisector does not have to go to a vertex. It just has to go through a side at the side's midpoint and to make a right angle with that side. Angle bisector bisects an angle in half. The other special segment that we learned recently was mid-segment, and I'll just scroll up to that just for a second. Just to recap, here's the mid-segment. It connects 2 midpoints of 2 sides of the triangle, and it's parallel to the third side and half of the third side's length. So that was the mid-segment. So that takes care of the review. I hope that these videos were helpful. I hope that some people watch them and learn from them, and that it helps you all to study for your test. And I will see you next time.